Here is a fascinating system of equations. We need to find the values of a and b, given that a squared minus b equals 21, and b squared minus a also equals 21. To solve this, let's use the elimination method. We subtract the second equation from the first. This gives us the quantity a squared minus b minus the quantity b squared minus a equals 0. Now let's rearrange the terms. We group the squared terms and the linear terms together. This becomes a squared minus b squared plus a minus b equals 0. We can factor a squared minus b squared as a plus b times a minus b. Notice that we now have a common factor of a minus b in both parts of the equation. Factoring out a minus b, we get a minus b times the quantity a plus b plus 1 equals 0. This product gives us two separate cases to investigate. Let's look at them one by one. Case 1. If a minus b equals 0, then b must be equal to a. Let's substitute this back into our first original equation. Replacing b with a, we get a squared minus a equals 21. Subtracting 21 from both sides, we get a squared minus a minus 21 equals 0. We solve this using the quadratic formula. A equals negative times negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 21, all divided by 2 times 1. Simplifying this, we get 1 plus or minus the square root of 85 divided by 2. Since b is equal to a, b shares these exact same values. This gives us our first set of solutions. Case 2. Now let's look at the second factor. A plus b plus 1 equals 0. Solving for b, we get b equals negative a minus 1. Again, we substitute this back into the first equation. A squared minus the quantity negative a minus 1 equals 21. Distributing the negative sign gives us a squared plus a plus 1 equals 21. Subtracting 21 from both sides leads to a simple quadratic. A squared plus a minus 20 equals 0. We can solve this by splitting the middle term. We need numbers that multiply to negative 20 and add to 1. Those are positive 5 and negative 4. So we factor this as a times a plus 5 minus 4 times a plus 5 equals 0, which simplifies to a plus 5 times a minus 4 equals 0. This gives us two integer values for a, negative 5 and 4. Now we find the matching b values. If a is negative 5, b equals negative times negative 5 minus 1, which is 4. If a is 4, b equals negative 4 minus 1, which is negative 5. So, bringing it all together, we have our final solution set. The two irrational pairs involving the square root of 85, and the two integer pairs, negative 5, 4, and 4, negative 5. And that is how we solve this symmetric system. If you found this helpful, hit that like button and subscribe for more math challenges.